mathematics, complete mathematics. Uh, Physics, class 11th, we are going to cover all the chapters. Whatever will be possible, let, let's work. Now we are going to start. First of all, let's start with basic mathematics. Here, uh, basic mathematics. Uh, as we know कि फिजिक्स है वो कॉम्बिनेशन है मैथमेटिक्स और थ्योरी का। इसलिए इसमें थोड़ा बहुत कैलकुलेशन, थोड़ा बहुत नहीं, आधा कैलकुलेशन पार्ट होता है जैसे मैकेनिक्स में, और थोड़ा बहुत इलेक्ट्रोमैग्नेटिक्स। तो इसलिए ये महत्वपूर्ण बन जाता है कि थोड़ा बहुत मैथमेटिक्स आना चाहिए क्लास 11th या 12th का, दोनों का कुछ चैप्टर्स मैथमेटिक्स का। उसमें से कुछ सिलेक्टिव है यहाँ पर, जैसे डिफरेंशिएशन एक चैप्टर मैथमेटिक्स में, उसी प्रकार इंटीग्रेशन है। कुछ ऐसे चैप्टर्स हैं जो कि यहाँ पर सिलेक्टिव है, और ये सब बेसिक बनते हैं फिजिक्स के क्लास 11th और 12th का। क्लास 11th और 12th का। तो यहाँ पर फर्स्ट ऑफ ऑल डिफरेंशिएशन है। डिफरेंशिएशन इसका मतलब होता है डिवाइड। डिवाइड यानी ये डिवाइड का एडवांस वर्जन। तो हमें कुछ कुछ याद रखना है, बहुत सारा है। जैसे y इज इक्वल टू, अगर x रेस्ट पावर n है, x रेस्ट पावर n, तो इसका डिफरेंशिएशन हो जाएगा dy अपॉन dx इज इक्वल टू एन एक्स एन माइनस वन, यानी एक पावर नीचे आ जाएगा, वो पावर नीचे आ जाएगा, और फिर ऊपर हमें एक से पावर को एक से घटाना है। उसी प्रकार y यहाँ पर cos कांस्टेंट का डिफरेंशिएशन जीरो होता है, और y e रेस्ट पावर x का होता है। थोड़ा सा लेट में सुनेंगे तो यहाँ पर ये y इज इक्वल टू कॉन्स्टेंट, अगर जैसे y इज इक्वल टू 2 है, 20 है, सिर्फ नंबर है, तो वो उसका डिफरेंशिएशन जीरो होगा। y इज इक्वल टू e रेस्ट पावर x, तो ये इसका जैसे यहाँ पर e, ये दूसरा चीज है। यहाँ पर e, अगर e आ रहा है और उसके ऊपर कोई वैल्यू है, e रेस्ट पावर x है, तो इसका सेम रहेगा। y इज इक्वल टू, इसका सेम रहेगा। पेज ऐड, जैसे y इज इक्वल टू ई रेस्ट पावर x है, तो इसका डिफरेंशिएशन सेम सेम रहेगा। जैसे y इज इक्वल टू एक्स रेस्ट पावर n, तो इसका डिफरेंशिएशन होगा dy अपॉन dx इज इक्वल टू एन एक्स रेस्ट पावर n माइनस वन। और याद रहे अगर y इज इक्वल टू कॉन्स्टेंट है, तो उसका डिफरेंशिएशन डी अपॉन डी एक्स इज इक्वल टू जीरो होता है। कॉन्स्टेंट यानी कोई भी नंबर, ओनली एनी नंबर, ठीक है, ये मतलब होता है कांस्टेंट। तो इसका डिफरेंशिएशन होता है। फिर यहाँ पर y इज इक्वल टू एल एन एक्स है। शायद ये log x होगा, लेकिन शायद नहीं भी हो सकता है। तो y इज इक्वल टू एल एन एक्स का याद रखना है कि इसका डिफरेंशिएशन होता है वन अपॉन एक्स, जैसे यहाँ पर दिया हुआ वन अपॉन एक्स। और y साइन का जस्ट कोस, अगर उल्टा आ रहा है तो कोस का माइनस लग जाएगा। जैसे 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 y इज इक्वल टू साइन है, तो साइन के बाद क्या आता है, उस तो इसका डिप्रिसिएशन पॉजिटिव में हो जाएगा, इसका cos थीटा। फिर उसके बाद है यहाँ पर जैसे y इज इक्वल टू cos थीटा, तो इसका अपोजिट होता है साइन और माइनस आएगा क्योंकि अपोजिट अपोजिट से याद रख। ये था थोड़ा बहुत डिफ्रेंशिएशन जो कि काम आता है इसमें। फिर इसके बाद है आउटसाइड इनसाइड रूल। आउटसाइड और इनसाइड रूल क्या होता है? जैसे यहाँ y इज इक्वल टू साइन 3x+4 है, तो यहाँ इसका डिफ्रेंशिएशन क्या होगा? फर्स्ट ऑफ ऑल हम डिफ्रेंशिएशन करेंगे इसका पूरा का साइन थीटा का, तो साइन थीटा का cos थीटा हो जाएगा। फिर उसके बाद एक एक टर्म करना है, तो 3x का 3 हो रहेगा, 3x का 3 रहेगा और 4 का 0 हो जाएगा। यहाँ पर वैसे क्या होगा, जैसे y इज इक्वल टू, यहाँ पर क्या है, y इज इक्वल टू साइन 3x+4। तो यहाँ पर क्या आ रहा है कि मल्टीप्लीकेशन दो से ज़्यादा आ रहा है यहाँ पर वेरिएबल्स या टर्म्स कह सकते हैं। तो इस केस में हमें याद रखना है कि पहले ये पूरा होगा इसका पूरा डिप्रिसिएशन, तो इसका पूरा डिप्रिसिएशन होता है cos थीटा, थीटा की जगह पर है 3x+4। फिर इसके बाद ये cos का हो गया, फिर इसको लेके चलना है, फिर सेकेंड टर्म को लेके चलना है। तो 3x का क्या हो जाएगा 3 और 4 का 0 हो जाएगा, 4 का 0 तो +0 हो जाएगा, +0। तो फाइनली हमारे पास इस तरह का आएगा इक्वेशन, इस तरह का इक्वेशन आएगा। एडिशन है a+b, फिर मल्टीप्लिकेशन, यानी अगर सिर्फ एडिशन में आ रहा है, एडिशन केस में, तो हमें उसको वन वन करके डिफ्रेंशिएट करना है। मल्टीप्लिकेशन आ रहा है तो पहले हम पहले वेरिएबल को कांस्टेंट रखेंगे और फिर दूसरा वेरिएबल को डिफ्रेंशिएट करेंगे, फिर उसी प्रकार वाइस वर्सा होगा। जैसे जैसे यहाँ पर y इज इक्वल टू a+b, y इज इक्वल टू a+b, इसका डिफ्रेंशिएशन करना है तो dy/dx हो जाएगा। तो यहाँ पर पहला होना चाहिए एक एक टर्म्स का डिफ्रेंशिएट हो जाएगा, तो यहाँ पर a/dx प्लस db/dx इस तरह का होगा। ये एडिशन था, ये एडिशन केस था। फिर इसी प्रकार मल्टीप्लिकेशन का, मल्टीप्लिकेशन का ए बी, तो इसमें क्या है कि y इज इक्वल टू ए बी, इसमें दो टर्म्स है जो कि प्रोडक्ट में। तो ऐसे केस में हमें क्या करना है कि पहले को कांस्टेंट रखना है, दूसरे को डिफरेंशिएट करना है, फिर उसके बाद प्लस, फिर पहला को दूसरा को कांस्टेंट करना है और पहला को डिफरेंशिएट करना है। तो जैसे पहला कांस्टेंट है और दूसरा का डिफरेंशिएशन हो जाएगा, प्लस फिर आप दूसरा कांस्टेंट आना चाहिए और पहला का डिफरेंशिएशन, पहला का डिफरेंशिएशन। ठीक, इस तरह का ये है इन द केस ऑफ मल्टीप्लिकेशन, मल्टीप्लिकेशन। ओके, व्हाट अबाउट डिवीजन, व्हाट अबाउट डिवीजन? सो y दिया हुआ a/b, इस केस में थोड़ा बहुत चेंजेस है, थोड़ा बहुत चेंजेस है। चेंज ये है कि जो स्टार्टिंग करना है हमें ये इस डाउनवर्ड टर्म से, b को कांस्टेंट रखना है, फिर a को डिफरेंशिएट करना है, फिर उसके बाद माइनस, क्योंकि डिवीजन में जा रहे हैं तो माइनस आएगा, अगर मल्टीप्लिकेशन में तो यहाँ पर प्लस है। फिर उसके बाद a को कांस्टेंट रखना है, फिर b को डिफरेंशिएट करना है, फिर ये डाउनवर्ड को स्क्वायर कर देना, डाउनवर्ड को स्क्वायर मतलब स्टार्ट करना है या डाउनवर्ड से। तो b को कांस्टेंट और एक को डिफरेंशिएट, माइनस, फिर यहाँ पर एक कांस्टेंट हो जाएगा, फिर b ये डिफरेंशिएट होगा अपॉन डाउनवर्ड को स्क्वायर करना। इस तरह से डिफ्रेंशिएट होगा। ये था इन द केस ऑफ डिवीजन, इन द केस ऑफ डिवीजन, और इट इज कॉल्ड एज कांस्टेंट। The next we have integration. तो y इज इक्वल टू एक्स रेस्ट पावर n का होगा कि पहले हमें बेस को ऐड करना है, फिर डाउनवर्ड में एक ऐड करना है बेस के साथ, कुछ इस तरह का। जैसे y इज इक्वल टू है एक्स रेस्ट पावर n, तो इसका इंटीग्रेशन हो जाएगा y इंटू डी एक्स, वाई इंटू डी एक्स, क्योंकि डी एक्स के रिस्पेक्ट में हो रहा है इसलिए डी एक्स यहाँ पर। तो इसका होता है एक्स n प्लस वन अपॉन n प्लस वन, बेस में ऐड हो जाएगा, बेस डाउनवर्ड आ जाएगा in the place of nominator। उसके बाद है y इज इक्वल टू कोस, y इज इक्वल टू कोस, कांस्टेंट है, कांस्टेंट का कांस्टेंट, कांस्टेंट। y इज इक्वल टू कांस्टेंट का, तो इस केस में इंटीग्रेशन ऑफ y विथ रिस्पेक्ट टू d, यहाँ पर हो जाएगा ax और इसका लिमिट्स x1 टू x2। नेक्स्ट है y इज इक्वल टू साइन थीटा, इसका डिफरेंशिएशन होना चाहिए y, तो थीटा के रिस्पेक्ट में हो रहा है डी थीटा, दिस इज इक्वल टू, इसका अपोजिट हो जाएगा तो माइनस कोस थीटा। नेक्स्ट है y इज इक्वल टू कोस थीटा, तो इसमें अपोजिट हो जाएगा डिप्रिशिएशन ऑफ y, इंटीग्रेशन ऑफ y विथ रिस्पेक्ट टू थीटा, इसका हो जाएगा साइन थीटा, साइन थीटा। नेक्स्ट y इज इक्वल टू वन अपॉन एक्स, नेक्स्ट है y इज इक्वल टू वन अपॉन एक्स, so integration of y with respect to dx is equal to ln x, ln x, इंटीग्रेशन ऑफ y अपॉन x, तो इसका हो जाएगा ln x, ln x, तो या ln x इसका सेम रहेगा a रेज टू पावर x, a रेज टू पावर x। फिर है आउटसाइड इनसाइड रूल, सो y इज इक्वल टू साइन थ्री, तो इसमें क्या है इंटीग्रेशन हो रहा है, तो पहले इस वोल टर्म को, फिर सेकेंड टर्म को, फिर थर्ड टर्म को करना है डिफ्रेंशिएट से, फिर डाउनवर्ड में थ्री आ जाएगा, डाउनवर्ड में थ्री, डाउनवर्ड में थ्री। इस डिफ्रेंशिएशन में ये थ्री मल्टीप्लिकेशन में था, तो जस्ट इसमें अपोजिट हो जाए बिकॉज वी आर इन इंटीग्रेशन, दैट्स वाई, तो ये मल्टीप्लिकेशन का अपोजिट हो जाएगा डिवीजन। तो y इज इक्वल टू थ्री एक्स प्लस फोर, वाई इज इक्वल टू साइन, y इज इक्वल टू साइन थ्री एक्स प्लस फोर, पहले इस वोल टर्म का, तो डी वाई अपॉन डी एक्स, तो इसका हो जाएगा माइनस कोस कोस एक्स, सो थ्री एक्स प्लस फोर, फिर इसका डिफरेंशिएशन थ्री का इंटीग्रेशन, तो ये डाउनवर्ड में जाएगा जस्ट अपोजिट, गॉट इट, इस तरह से। Uh, this was outside inside rule. Next we have addition. In the case of addition, एक एक टर्म को इंटीग्रेट करना, एक एक टर्म को, जैसे जैसे y इज इक्वल टू a प्लस बी, तो इसको एक एक टर्म को इंटीग्रेट करना है। इंटीग्रेशन ऑफ y विथ रिस्पेक्ट टू dx इज इक्वल टू इंटीग्रेशन ऑफ a, यही हो रहा है, इंटीग्रेशन ऑफ a विथ रिस्पेक्ट टू dx, इंटीग्रेशन ऑफ a विथ रिस्पेक्ट टू dx, देन ऐड, अगर लिमिट्स है तो यहाँ से यहाँ लिमिट्स हो जाएगा, फिर उसके बाद इंटीग्रेशन ऑफ अ सेकेंड टर्म b इंटू डी एक्स। तो ये था एडिशन केस में, एडिशन केस में। उसके बाद है we have a question, some questions जैसे r is equal to ft square minus 3t square plus 70 plus 9, find velocity when acceleration is 0. Find the relation between, these are some question, ये तो काइनेमेटिक्स का क्वेश्चन है, why काइनेमेटिक्स, काइनेमेटिक्स। e raised to power, let's start with vector chapter. Vector chapter is, what is a vector? As we know that vector is nothing but it has a magnitude and a direction. It also obey the rule of vector algebra, like triangular law, rectangular law, मीन्स इसके पास मैग्नीट्यूड होता है, डायरेक्शन होता है, और ये वेक्टर अलजेब्रा को फॉलो करता है। फॉर एग्जांपल दिस इज अ वेक्टर और इसके पास मैग्नीट्यूड है ये, और ए कैप इसका अपना डायरेक्शन, ए कैप इज आल्सो नोन एज यूनिट वेक्टर। इसके पास थ्री डायरेक्शंस होते हैं, आई जे के कैप रिप्रेजेंट डायरेक्शन। यूनिट वेक्टर का स्पेशल डायरेक्शन के लिए यूज किया जाता है। ए कैप definition is it has only one magnitude and it is represented like this: a cap is equal to vector a upon magnitude of itself, vector itself vector. Example, we have 3 I cap plus 4 j cap. तो in that case इसका जो unit vector होगा which will be this complete, this will be written over here, and magnitude of it will be 5. And now we have a 3 I cap upon 5 plus 4 upon 4 upon 5 j cap. ये है यूनिट वेक्टर. So over here जैसे यहाँ पर वेक्टर के पास मैग्नीट्यूड होता है, डायरेक्शंस होते हैं, और ये वेक्टर दो अलजेब्रा को फॉलो करता है. तो एग्जांपल से जैसे कोई वेक्टर हो सकता है, इसके पास एक मैग्नीट्यूड होगा और एक डायरेक्शन होगा, एक कैप. यहीं से आता है यूनिट वेक्टर. हाउ टू कैलकुलेट यूनिट वेक्टर? हाउ टू कैलकुलेट यूनिट वेक्टर? तो आंसर इज ए कैप यहाँ रहेगा और ये वेक्टर अपवर्ड और फिर ये डाउनवर्ड. दिस इज अ यूनिट वेक्टर. इस 3D dimension में there are three axes in the form of vector I cap, j cap and k cap. Angle between second angle between vector, how to calculate? We need to see which angle is small. For example, over here, this is angle. Uh, there are two angles in this case. This bigger and this is smaller. So we have to take a smaller angle. And here you can say this is a smaller angle. This is a smaller angle. In that case, when it comes to find the angle between two vectors, just take a small angle. You will get a bigger and a small. You have to select a small angle. So it is done. What is the definition of a vector? How how is it represented? We have seen it. Uh, how to find a unit vector. So this unit vector came from this a small equation, and this is a definition of a vector. We saw how to identify, how to calculate, how to find out the angle between any two vectors. So in this condition is only one, you have to take a small angle. Next topic, which is types of vector. There are a lot of, not a lot of, there are certain. Just we took over here in this page only few, 3, 3, 6, 9. There are 9. So first we have equal vectors. So equal means magnitude. For example, there are two vectors. So both has the same magnitude and same direction. For instance, this is a vector. So a vector, let's say it has a 5 centimeter, which is the magnitude, and direction is the same. So beam vector will have also 5 centimeter magnitude. Then that's why it is known as this type of vectors will be called as equal vectors. So parallel means angle will be zero. Angle will be zero. Here magnitude can be more, can be less. But in the case of equal vector, magnitude of both vectors should be. In the case of a parallel vector, uh, magnitude of each other will be different, could be same. And one more thing for the parallel vector is that angle between those two vectors should be 0 degree. 0 degree. That's why parallel word came to say one more thing, which is angle between them should be 0 degree. Just here, anti word is added. Anti word is added with the parallel vector. It means opposite. So direction is opposite, and everything for the definition would be same. Magnitude magnitude of both can be less, can be more. But main thing is direction will be opposite and angle will be 180 degree. Next we have negative vector. Uh, Here we need to take a little bit focus on negative vector. It explains it itself by saying that magnitude magnitude would be same but opposite direction. Just we will convert direction uh, in opposite, in opposite, completely in opposite. If this is in this direction, so we will convert, magnitude will be same, just we will convert, we will change its direction, nothing else. Next we have collinear vector. Collinear. From this word, we can understand what is it saying. It is saying that collinear means there are a lot of lines. There could be a lot of lines, but all the vectors should be in same line, in same line. All the vectors should be in same line. Magnitude could be less or more. Coplanar means on a plane, on a plane. There are few vectors, one, two, three, four. Number of vectors could be less or more, but but main thing is all this should be on a single plane. Okay, on single plane. Orthogonal means angle between two vectors is 90 degree. You can see means one vector is perpendicular to another vector. This is the meaning of orthogonal vector. When it comes to orthogonal word, just understand 90 degree angle. Yeah, 90 degree angle. When you think 90 degree angle, it means there are two vectors and both are making 90 degree angle. In other language, in other word, in other definition, you can say one vector is a perpendicular to another vector. Unit vector, this is used many times, majority times. It will come in our 11th standard or 12th standard. It helps a lot of, yeah. So when it comes to types of a vector, teacher will say, yeah, unit vector is a special for you for your 11th and 12th standard. It will come a lot of a time in in a theory, but in calculation, a lot of a time will come. Yeah, this is a truth. So uh, it is not easy as we were discussing equal vectors. We were saying same magnitude, same direction, little bit. Unit means one. It also not a difficult to understand. It is also not a difficult to understand. Unit means one. It's the same magnitude of it's is a one. Magnitude of it is one. And this unit vector is used a special for direction, a special for direction, because magnitude is going to be fixed. Magnitude is fixed for always for the unit vector. So what is the main you can say quality? What is the main quality in this vector? So answer is direction. Direction. For example, I is a cap. So here I cap has it is unit vector and it has only one magnitude. Say cap has only one magnitude. K cap has also one magnitude. But main thing is that this I cap in our Cartesian plane, you will see I cap is in this direction and Y cap is upward and the J cap is outward, or it can be inward. So direction will play a crucial role, I would say. Uh, Last one, which is null vector. Null means zero. So what is the zero? Magnitude is zero, and you can see in that case displacement. You know what is the displacement. So here, what happens with the displacement? Same will happen with null vector. Here, in the case of a displacement, yeah, if a circle, so displacement we get if one person start from a point and after few time he came to the initial point, to the same point. In that case, we say displacement is zero. Same over here. Or same over here. You can see It is started from here and it came over here. So here magnitude is 0. Magnitude is 0. Now properties of factor, let's see. First we have addition of factor, then multiplications and the division. So addition, here we are going to see how to add factors, how to multiply factors, how to divide factors. Uh, there are different rules. It's not like 5 plus 3 it is going to be 8. Yeah, 5 plus 3 is 8. But to add in this vector form, it is a little bit different. I will show you with example. So first of all, let's complete addition of a vector with a scalar. Then we will see with a vector. A scalar, it's very simple. It's very simple. When it comes to a scalar, we just take a magnitude, not direction. We just talk about magnitude when it comes to a scalar. We need to take care about only magnitude, not direction, when we are in the case of a scalar. So 5 plus 3 is equal to 8 was an example of a scalar. But when you will go in the context of a vector, things will change. Here 10i, here 10 is only magnitude. So I cap is a direction, and we know what is the definition of vector. It should have a what? It must have a direction. So here direction is what I cap. J is a direction, K cap is a direction. If you take only 10, 2, 3, it will become scalar. Already we have discussed as scalar just right now. Now we are discussing about the vector. So you can see what is the quality inside it. Quality is a direction. So 10i plus 2j plus 3k. Now how to add this? How to add? Question will be arising in the matter. Yeah, we can add 10 plus 2 plus 3. It would be 15. But what about Isaac and Isaac k? So magnitude of this, magnitude of r, this there is a formula under root of 10 square, 10 square plus 2 square plus 3 square. Here we applied a mode. Mode means it is going to remove direction. It is going to remove negative sign. That's why this mode is used. That's why this mode is used. Okay. This was the case of addition. Now let's see multiplication. So with a scalar, just simple 3i multiply 10. So over here it will become 30i. But 3i multiply 10 z. In that case, it will become vector. It will become vector. So with vector, it depends on types of multiplication. Is it cross product or dot product? So how to identify? Let me explain. For example, you are multiplying two vectors. You have a two vector and you are going to apply. You are going to multiply two vectors. Those two vectors. You see, result is again vector. In that case, this multiplication will be known as cross product. This multiplication will be known as a cross product because answer answer is a quantity which is a vector. Again vector. When you multiply two vectors and again resultant came as a vector. So that's why this will be known as. On the other side, dot product means yeah we are multiplying two. We are multiplying two vector. But what is happening? Answer is coming as a scalar. In the first case, there was vector, answer was vector, result was a vector. But now we are multiplying two vectors, but answer is coming as scalar. This was a difference. So once this one, it was named as a cross product, and this multiplication was named as a dot product. Here cross means just this simple cross will come and this just a symbol this dot will come. Result of both will be different, of course. Now next we have a division of vectors. So division of vectors, first of all we will do it with a scalar, then with a vector. Remember, you have an interesting point. You don't need to take about the division for the vector. This concept of multiplication of vectors will help you in your standard. You don't need to take care about division of vector because it is not possible. With a scalar, this is possible. 10I cap upon 2. This will cut by 5. So 5 I cap. It is very easy. Na? This scalar is very easy. And in this your book, your classes, scalars about a scalar will not be discussed a lot of, but little bit for the introduction. Your whole point will be vector. Vector. Direction of a vector from different axes. From different axes. Here we just fix that this side horizontal will be x cap, this vertical will be y cap, and inward and outward is going to be z cap. And we say if we draw like that from origin till the point, this is a position vector, and position vector has a this is represented by r vector, and it has a three direction because this is a present in three dimension. If it is a present in two dimension, just we will take two axes. But right now we are just assuming that this is the present in three dimension. So of course it has a three direction. This x, y, and z. With the x it has a I cap, with y it has a j cap, and with its j cap, with the z it has a k cap. Just I, j, k, all these are in vector form, and x, y, z, all these are in coordinates form, in coordinates, in Cartesian. So cos alpha over here, this cos alpha will be what? According to this theta, so cos alpha will be s upon hypotenuse. So x upon r, and cos beta, this will be your y upon r, and cos gamma, it is equal to z upon r. Z upon r. So axes are upward and in downward resultant. Then is here uh, this formula uh, is taught by teacher because when question will come, then we will use this formula. There are some questions based on this formula. So what does it tell? What does it tell? It tells you uh, calculating third vector. Calculating third vector. For example, you have given two vectors, this one and this second b. So what would be resultant? So resultant by using this formula you will be able to calculate by using this formula. So for to calculate resultant, we have to use a formula. And you know why formula is used? It is used so that it can save our time, and it can avoid our confusion regarding this. and more. Anyhow, this is useful to use from. So how did it come? Let's say r vector under root. There is a derivation, but in this case, it is a revision, a base. So just formula is written. Uh, Formula is r vector to calculate r vector under root. So first of all, this magnitude of a vector, it's a square. Then plus magnitude of a b vector, it's a square plus 2ab posted. Here I think a plus b a square. Yeah, a plus b a square plus 2ab cos theta plus b a square. Yeah. So okay, ignore it. Just say under root of a square, magnitude of a direct vector. So a square plus b square plus 2ab in under. This will give us resultant one. Resultant. This was a triangular. Now for rectangular. This one a vector, this b, and this at the same bisect. This is our resultant vector. Resultant vector. Here a, this is a vector, this is a vector. So our resultant would be root a. Because the angle is a 90 degree. Just keep it over here 90 degree, and here a and a will be 2a, and this cos 90 is 0, so this term will become 0, and under root 2a will left over here. Now here degrees is 60, so cos 60 by 2, 1 by 2 a then 2 root 3 by 2, it would be root 3 by 2, so 2a, so 2 will cut to each other, and 3 by root 3 by, that is how it came. Now angle is 120 degree, both vectors are same. uh, Resultant is like this. Just put 120 angle in this formula, you will get your resultant. Maximum magnitude. Maximum magnitude. Maximum magnitude we will get at 90 degree, and minimum magnitude we will get at 0 degree. At 0 degree. For example, 3 sine theta plus 4 cos theta. So angle between them is 90 degree. So this is our maximum. Maximum. Now dot product. Dot product. As I told you, dot product. This is also known as a scalar product. There are ways to multiply two vectors. One is by multiplying two vectors. If answer resultant is coming vector, this will be known as closed product. In the other case, we do multiply two vectors, but answer is coming a scalar one. A scalar one. So for a scalar we have a dot product, for vector we have a cross product. So AB, there are two vectors, AB vector and dot B vector. Here we are multiplying it. So remember, formula is for this AB cos theta. AB cos theta. From this just opposite of S will be cos, and opposite of C will be sine. So from here we will get angle. If question is saying find, we are giving to equation from the equation side. Question is saying we are providing two vector and you have to multiply them and then find out the angle between. Either question will be like this. So there are two vectors, angle between them is this much and calculate this, multiply this. Second question could be we are giving you vector A and vector B and value of vector A and value of vector B. Everything is given except theta. Then we can use this formula which is coming from from over here. If theta is 90 degree, AB will be 0 because cos theta is 0 and all these are in multiplication. So this whole term will become 0. This is important over here. If there are two vectors which are same, magnitude is same, direction is also same. In that case, remember here same vectors, same magnitude. Same vector, same magnitude. It means angle is 0. Angle is 0. And cos 0 is 1. Same over here. J cap into J. Answer is 1. K cap into K. Answer is 1. Reason is, main thing is theta is 0 and cos theta is 1. And apart from, except this, for example, I into J cap. And 90, here 90 is becoming, angle is becoming 90 degree. And cos 90 is 0. So this is saying that except this, you just take different, but factors should be different. If one is I, second should be J, either it could be K or J. And you will see angle is becoming 90 degree. So answer will be, resultant would be 0. If theta is 90, answer would be 0. If theta is 0, answer would be 1. And there are two vectors. Those vectors should be same in the term of magnitude and in the case of direction. This is one example. As you know, I cap will become 1. So 5 to the 10. And here 3 plus minus minus. So 3 ones are 3. Minus plus minus 8 to the 16. Just simplify it. Okay, next we have cross product. There are two vectors. Let's multiply. A, B, sin theta. Direction will be like this. After I, if this it is coming J, then next direction will be K. It's a K, and after it is I, so next will be C, like this. This is a circle. This will provide us exact direction. Keep it in your mind. For example, I and 2J, both are different. It means angle are 90 degree. Magnitude is the same. Angle is just 90 degree. And sin 90 is 1. So direction. Now it comes to direction. Main thing in this case is a direction. So I, then J. So after this, what will be? K. Next, J, I. So J, I, then it is going like this. J, then I. Now after this, K. K. So here, this is anti-clockwise. For the anti-clockwise, negative sign, just apply negative sign. J into K. J, K. So direction is clockwise. So for the clockwise, just positive sign. For the anti-clockwise, negative sign. So I, K. So I, K. Here you can see this is a anti-clockwise. So for the outward, we have signed this. This is an example of cross product. Let's see motion in a straight line. Motion in a straight line. We know any object which is even in front of you, there would be a lot of objects which are some would be in a rest, some would be in a motion. Objects that are in rest, we say object is in a rest. Objects that are in motion, we say objects are moving. From this little bit concept, this chapter starts. This chapter begins. So distance is what? This is actual part. It is a scalar quantity. It would be positive always. And we just take actual part. Actual. It does not need direction because it does not provide proper direction. Displacement. This is vector quantity. But definition of this displacement is we take just initial point and final point. So final minus initial comes as a result of displacement. This is vector because for this direction is a compulsory. So that's why this is called as this quantity is known as a vector quantity. One factor for both distance and displacement is distance will be equal to distance would be equal to displacement. Distance displacement would be less than distance, but displacement will not be greater than distance. This was the main fact between. This is one factor for this. Here you can see. So here just apply what magnitude, not magnitude. Next we have a speed velocity. Again, a speed is a scalar quantity and velocity is a vector quantity. So for the speed, we take average. So just we will take total distance upon total time. Simple. But for the average velocity, we take total displacement and total time. So here displacement is already vector. So this velocity becomes vector quantity. Here we don't think about a lot of about the average velocity. Here focus would be on velocity, average velocity. So average velocity is equal to v1 plus v2 upon if equal interval time. If time is equal, in this case, equal distance interval. Equal distance interval. Next we have a circle. Circle. Here there was a one point and it covered some distance to tell you. So what would be displacement and distance? So this arc is going to be distance and this straight line is going to be displacement. But question is how to calculate mathematically. We know arc is equal to r theta. Theta is equal to arc upon r. By this formula we will get this arc will give us distance and this what x is equal to 2r sine theta upon 2. This is displacement. This straight line will provide a displacement. When a is a constant and v is a velocity, S2 motion. After velocity, there is another quantity which is the acceleration, average acceleration. Formula is definition of it says change in velocity u2 minus v1 upon t2 minus t1. Average means integration. Instant means differentiation. Instant means at instant time. What was the acceleration of object? So this will be equal to dv upon dt. This is also equal to d square x upon dt. This is also equal to v into dv upon dx. Retardation, acceleration in opposite direction of motion. It means acceleration is in opposite direction of motion. When acceleration is a constant, then this equation is used. But if acceleration is a variable, then integration or differentiation will be used. These are some equations of motion. V is equal to u plus at, s is equal to ut plus half at square. V square minus u square is equal to this. There is a motion which is under gravity. Case number 1. It perhaps will happen just dropped. Just an object was dropped and use the Galileo's law. V ground is equal to under root 2 gh, where g is acceleration due to gravity and h is a height. This was an object which was dropped from this height, this certain height. Initial velocity was 0, and when it came to here, it covered a 5-meter distance, and velocity over here was 10 meters per second. Gradually, it decreased. It increased. Reason is as gravity. Now, after 1 second, it increased, then more increase, then more. For the time, we have t is equal to under root 2. I don't know what is it, and upon c. Case number 2, ground to ground. Yes, from ground, a object was thrown upward, and then object came downward. Object came downward, reason is again acceleration due to gravity. At the top, velocity became 0. That's why that object came downward. So this time t1 and this time t2. t1 plus t2 will be time flight. Time flight means how much time was taken by this object to came on the ground. This is known as a time flight. H maximum was how much? So this formula will give us H maximum. Time flight is equal to t1 plus t2, and only time, how much time was taken, this formula will provide 2u upon z, or it is equal to 2 under root of 2x upon z. If air resistance present, so for the upward acceleration, if it will be g plus a. For the downward, it will be g minus a. Case number 3, height to ground, like this. So over here, h will be our ut plus ut minus half gt, and t will be time up plus a time, total time taken by this. And this is our height. To calculate this, use this one. This was the third case. Now next we have stopping distance. Stopping distance means when brake was applied, after brake, how much time was taken by that vehicle just to stop completely. So that distance was covered by that vehicle is known as stopping distance. How much distance was covered by that vehicle after applying brake? This is what is the stopping distance. To calculate this, we have a equation S is equal to U square upon 2G. And what is it? Next, we have a relative motion in 1D. 1D. Remember, this slope will provide us zero slope. Relation motion under gravity. Relation means we explain one thing with respect to frame of reference. With what frame of reference we are saying that this object is this object in rest or motion? With what reference? That reference will play a role. These are graphs. The xt graph provides velocity and vt graph provides acceleration. Area under vt, it will provide. Okay. So vx will provide acceleration. At will provide what? Change in velocity. Change in velocity. This is an impossible graph. Graph will not be like this. Here you can see distance is becoming negative. You know, fact is about distances. It is not always negative. This distance does not provide negative distance. And this is sharp, not sharp. It is not completely sharp because objects takes some little time to stop. This is impossible.